Hi guys, it's me, Mr. Bertoch, your incredibly handsome science teacher. And in this video, we're going to talk about Newton's third law of motion. Once upon a time, in the land of England, there lived a guy, and his name was Isaac Newton. And he was he was a smartly fellow. And because he was so smart, he was able to use his mind to do amazing thought experiments and to make discoveries that really weren't possible at the time with the technology that they had, and wouldn't be possible for centuries, because he had to imagine how things would work in outer space. And so he used this power of his brain to discover such amazing things as the laws of motion and gravity and a whole bunch of other stuff. This guy's name, by the way, was Isaac Newton. And in other videos, I've talked about his first law of motion and his second law of motion. In this video, I'm going to talk about Isaac Newton's third law of motion. The third law of motion simply states that to every action, there is an opposite and equal reaction. And that's it. End of video. Okay, we're done. Okay, not really. Let's talk a little bit more about what it means, but it's really not that complicated. Okay, to every action, there is an opposite but equal reaction. What does that mean? So, if I go into outer space, which is a place where Isaac Newton could not go, and yet he figured this out. If I go into outer space and I take my identical twin, another handsome science teacher, and I shove that handsome, because I'm jealous of him. I'm like, I'm the only handsome science teacher around here. And so I shove my identical, I don't actually have a twin, by the way, but if I did, I would murder the twin in outer space. And this is how I would do it. I would shove the twin backwards and away from me. And what would happen? Well, I would end up murdering myself too, I guess, because we would both fly off in opposite directions from each other with equal force. So whatever amount of force I apply to my identical twin, he's going to go in one direction, I'm going to go in the other direction, and we're pretty much stuck forever flying away from each other in opposite directions until somebody rescues us, because we can't really change our direction. Okay, so to every action, there's an opposite and equal reaction. Now, you have to keep in mind that not all things are the same mass. So if I have a mini Mr. Bertoch, like a bobblehead Mr. Bertoch, which I should totally get. I don't have a bobblehead Bertoch, but that would be awesome. And I take my bobblehead Bertoch, and it's still so handsome that I'm jealous of it. And so I throw it in the opposite direction. Well, that thing's going to go flying pretty fast. What's going to happen to me? Am I going to fly off in the opposite direction? The answer is yes, but with an equal amount of force, but I'm so much more massive that I'm going to go off in the opposite direction, but very slowly compared to how fast the bobblehead Bertoch flies away from me. Okay, so you have to account for mass. Now let's apply this down here on Earth. Let's not talk about murdering Bertoches anymore, Bertoches of all sizes. And instead, now let's talk about what happens when we're down here on Earth. So right now, chances are you're probably sitting somewhere or standing somewhere. I suspect you're not floating. Never know, you might be. But more than likely, you're not watching this while floating in outer space. So you're probably sitting, more likely than not sitting. You might be standing. So let's pretend you're sitting. So you're sitting in a chair, and the weight of your body is squishing downward because gravity is pulling you down into the chair. Well, what does Newton's third law of motion tell us the chair has to be doing to you? If you're pushing down on the chair, and we know that to every action there's an opposite but equal reaction, what is the chair doing to you? It is pushing up. If you're pushing down, the chair has to push back up, or what would happen? There has to be a balance of forces. Otherwise, you would fall through the chair. If the chair doesn't push back up against you, then it's going to go down and you're going to go through it and hit the floor. Likewise, if the chair is pushing up harder than you're pushing down, what's going to happen? We call that an ejection seat, and you're going to go flying away through the ceiling and hopefully have a parachute. So that forces are imbalanced. Every action, there's an opposite and equal reaction. When you sit on your chair, if the chair doesn't push back up, you're going to go down. You're going to fall down. If the chair pushes up too hard, you're going to fly. You're going to be ejected, and you're going to go and fly away through the ceiling. So there's an opposite and equal reaction, which allows you to sit on the chair and be in balance. Okay. Think about my pet elephant. If I had a pet elephant, I would be very happy. I do not have a pet elephant, but if I did, that would be great. And let's say I tie a leash to my pet elephant, and I take my pet elephant Stampy for a walk, and I try to pull on Stampy's leash, and Stampy refuses to go anywhere. The harder I pull, if Stampy isn't in the mood to go for a walk, what does he have to do? He has to pull back with an equal force, right? So we can understand this when we're thinking about an elephant because, I don't know, it just kind of makes sense to us. Stampy the elephant has to pull back on his leash with the exact same amount of force. If he pulls harder, he's going to pull me. And if he pulls softer, then I'm going to be able to pull him. So he has to keep the force balanced. Now, let's say I am something and I'm confused and I put my leash on a telephone pole for some reason. And I try to take the telephone pole for a walk. Is it any different than an elephant? It's not. It seems different, but it's really not. If I pull on the telephone pole, it has to pull back with the same amount of force as I am pulling. If it pulls back with less force, then it's going to come towards me. If it pulls back with more force, it's going to pull me towards it. Okay. So the telephone pole does, even though it seems like it's doing nothing, it's just sitting still. Well, it is just sitting still. But the reason it is able to stay still is because it pulls back. It matches my force. Now, if I were really strong, eventually I could overcome the telephone pole, and I could pull it so hard. I'd have to have a better leash. My leash would snap, but if I had like a chain, I could pull so hard that it would overcome its ability to pull back. And then what's going to happen? When I reach that point, the telephone pole is going to snap, and it's going to come towards me and probably land on me and crush me and kill me. And that will be sad. That's a waste of handsomeness. But you can visualize, you can imagine, because you're doing a thought experiment. You can imagine, like Isaac Newton imagined, like he did thought experiments. You can see how this works. So whether it is Stampy the pet elephant or my pet telephone pole, they are both going to either match the force, and then we're both going to stay still. One is going to pull harder, and then if the elephant or the pole pulls harder, I'm going to go towards them, or they're going to pull less hard, and then they're going to come with me, and I'm going to be the boss, and I'm going to take the telephone pole for a walk around the neighborhood and get all kinds of looks, or the elephant, and that would be awesome. So that is Newton's third law of motion, that simply to every action, there is an opposite but equal reaction. And in space, that means I can throw things and I'm going to go off in the opposite direction. On Earth, it means wherever I stand or sit, things push back against me with an equal force. And if they don't, I go down. Or if they use too much force, I go up. Or if we're going left and right or forward and back, and I'm trying to take things for walks or pushing boxes around the room. If I want to move a couch from one part of the house to the next, I have to exert more force than the couch is able to push back. If I push the couch softly, the couch is going to not move. But once I can push hard enough to overcome its ability to push back, then it starts to move, because it can only push back with a certain amount of force. And that is Newton's third law of motion. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.